Ask an expert. Charles R. Price, Grandpa and NASA expert for Bloomfield Hills Middle School, February 2015.
Hi, I'm Charles Price, Rosie's grandfather. I've worked at NASA since 1963 as an engineer. That's a total of 52 years. Today, Rosie and I are going to discuss spacecraft and robots. NASA is the National Aeronautics and Space Administration. We're an organization of American people who study space, who build spacecraft, and who operate spacecraft. Some of the NASA people are astronauts. I've analyzed trajectories for flying to the moon and landing the shuttle. I've managed the development of the shuttle backup flight computer, also the laboratories in which the navigation equipment were developed. And I also worked on robots. Okay, how did I get interested in space, Rosie? Well, when I was about your age, I saw a movie. Also, about 6 years later, the Russians launched the Sputnik. We'll talk about both. I saw the movie Destination Moon when I was 11. 18 years later, we landed on the moon, and I had worked on the spacecraft that went to the moon. Just think yourself about something you'd like to do, and maybe in the future, you'll be able to participate in making it happen. The Russians launched the Sputnik, which was the first satellite ever launched into Earth orbit. It frightened us in the U.S. because it flew over us without our permission. So we vowed that we would learn how to send other spacecraft into space. Now there's more than 3,000 satellites in orbit. Okay, some of the questions that you might ask is, how far away is space? And how do we get there? And what in the world is an orbit? Okay, how far away is space? Well, it's 20 miles straight up. That's not that very far. It's like driving from your school, perhaps to the Detroit Institute of Arts, if you've been there, or perhaps to Lake Orion. They're both approximately 20 or 25 miles away. Or go to see a Tigers game, or go to a robot competition. Okay, we're going to do a demonstration of the distance of the height of the GPS satellites and the distance of the moon away from the Earth. So here's our Earth again, and the height of the GPS satellites that we're able to navigate with in our phones is 12,000 miles. That's about to the top of this yardstick. There's 24 of them circling the Earth at all times. Okay, the moon is much farther away. Rosie, take this apple, which is the size of the moon relative to this size of the Earth, and let's walk the distance off. That's a distance of 240,000 miles, or 30 feet here on this scale. Okay, and if Rosie holds the apple in front of her eye, she'll get the same sensation that the astronauts did when they first went behind the moon and lost sight of Earth. They were behind the moon for almost an hour. We could not talk to them. They could not talk to us. They could not see the Earth. This was the first time humans had ever been out of sight of the Earth entirely. Okay, Rosie, it takes a lot of fuel to get something into orbit. Say we wanted to launch this 12-ounce can of juice into space. How many cans of fuel this size do you think it would take?
I don't know. A lot, maybe?
A lot? Let's see. Let's count them. 1, you count.
2, 3, 4,
7 times the amount of weight in fuel in order to launch this into orbit. And when the rocket takes off, it uses the fuel from the bottom first and throws away those cans first. That way it gets lighter and lighter as it goes up. And finally, this is the only thing that gets into orbit. Rosie, what is a satellite?
A satellite is an object that revolves around another object with a stronger gravitational pull.
Right. And did you know that most satellites travel in an orbit that's nearly circular?
Yeah.
Okay. And this is a circle. So describe on me with your finger how a satellite would go around it.
Like
right.
this.
Yes. Okay. So if we had the Earth, which is actually blue, and you had a satellite in orbit, would it be up here?
Nope.
No? Okay. Would it be down here?
It would be down there.
And would that be the only place?
Nope. It could be like this, like this, like this. As long as it's around the planet's center, or it's considered in orbit.
That's right. And do you know how long a satellite at a low altitude takes to go around the Earth?
A week?
No, it's like an hour and a half, 90 minutes, so they move very fast. Okay, in this picture, the 24 GPS satellites are the ones that allow us to navigate with our phones to where we're going to drive to. Okay, the dots in here are the satellites, and then the lines represent the orbits. This is the rocket that we used to send the astronauts to the moon. It's 360 feet tall. And as you see here, it was mostly fuel. The only thing that came back was a little white triangle near the top, and it parachuted into the ocean, and the astronauts were picked up by the U.S. Navy. This is one of the American astronauts on the moon. The flag is not being blown in the wind because there's no air on the moon. It's being held up by wires. The astronaut is jumping above the surface of the moon because on the moon you only weigh 1/6 of what you do on Earth. In 1975, we wanted to send more astronauts to learn about the Earth and space, so we built the 5 space shuttles. In 1981, we launched our first space shuttle. The 5 space shuttles altogether flew in Earth orbit 135 times. Notice that the shape of the shuttle was different from the moon rocket. The wings allowed it to land on the Earth rather than the ocean. The shuttle could carry as many as 7 astronauts into space and bring them back. It also could carry up to 65,000 pounds of a payload that it could either leave in orbit or it could be brought back to Earth. During its 20 years of service, the shuttle delivered the Hubble Space Telescope and other observatories into orbit. We learned how to work in space. This was one of my favorite missions. It carried an experiment that I worked on for fuel transfer. In the picture in the center, you see 2 astronauts in their white spacesuits working on the experiment. The 2 are Catherine Sullivan and Dave Leesma. They're in the lower right-hand corner of the picture of the crew. The space shuttle landed like an airplane. This allowed us to clean it up, refuel it, put it back on the stack so it could be launched back into space. It was reusable. Each of the 5 shuttles flew on average about 25 missions. After they were retired, the shuttles were put into different museums around the country. You can go visit them there. Here is a full-scale replica of one in Houston that our family visited last year. The biggest job that the Space Shuttle accomplished was building the International Space Station. It took 75 flights of the shuttle to build this largest of all spacecrafts. The space station is huge. It weighs 1,000,000 pounds and it's 300 feet long. It took over 10 years to build, and it involved the United States, Russia, Japan, Canada, and Brazil, and the 25 countries in the European Space Agency. What is life like on the space station? It's a weightless environment, so you can pick any wall you want to be your floor. The crews that are in the space station usually number 6 or 7, and they perform a lot of work inside, but occasionally they have to go outside and perform work there as well. In this picture, the astronaut in the spacesuit is being moved from one position to another on the manipulator arm or robot arm that was built by the Canadians. In the other picture, an astronaut is showing how much fun it is to be able to swim in a weightless environment. NASA has 3 kinds of robots. One is the large space crane on the space station, or the manipulator arm as we saw in the previous picture. The second kind are the rovers that we sent to Mars, and the third kind is the Robonaut, which looks very much like a human. This is the entire Canadian-built robot. The long manipulator arm attached to a mobile base that can move it from one place to another on a rail, and a complex end effector on the other end that's used to pick up and exchange large pieces of equipment. NASA sent robot rovers like these to Mars. The smallest one at the bottom went first about 20 years ago. The one above it is now operating for 11 years on the surface of Mars. The large one to the right was sent about 2 years ago, and it's called Curiosity. This is a picture of the surface of Mars from above, and inside the blue ellipse is where Curiosity landed. This is a closer image from above. The bright spot in the middle towards the top is Curiosity, and behind it, if you look closely, there are twin trails of where its wheels left tracks in the surface of Mars as it went about its scientific investigation. The third kind of robot is the ones that look somewhat like humans. I started this robot called DART in our lab in Houston in 1993. The purpose of this robot is to be able to pick up the tools that the astronauts use on their spacewalks. Since I left Houston, the people that I hired to build the robot have improved it greatly. It's now called Robonaut, and it indeed can pick up and use the tools that the astronaut used. Here's a picture of it in the space station. And since we're in Michigan, I must point out that this version of Robonaut that's on the space station is a product of a partnership between NASA and General Motors right here in Michigan. NASA has many space exhibits across the country and has one right now at the Cranbrook Science Museum. Science students like you are very important to NASA and to America. Enjoy learning your science, and you will do marvelous things in the future.